So, a very warm and precious good morning to everyone. Today, me and my team members are going to present the topic NFC. So, I am Omika Singh going to introduce about NFC. So, NFC stands for Near Field Communication. It is a short range wireless technology that allows device to communicate when they are very close, usually within 4 centimeters. It is based on RFID technology and works at a frequency of 13.56 megahertz. Because of a short distance, it is fast, secure, and easy to use. We commonly see NFC in smartphones, smart cards, uh, contactless payments, and access control systems like entry cards. Now we'll talk about the working principles of NFC. NFC NFC works usually using electromagnetic induction between two devices. One device acts as a initiator and other acts as a target. Communication start when they are brought close together. There are three modes: reader-writer modes, where a phone reads NFC tags; peer-to-peer modes, where sharing data between devices; and the last, card emulation mode, where the phone act like a smart card of payment. NFC is low power, contacts quickly, and provides secure communication. So that's it from my end.
My name is Niranjana, and let me explain how NFC communication actually works in real world systems. So, NFC mainly operates in three different modes depending on the use case. We have peer to peer mode, card emulation mode, as well as the read write mode. So first is the peer-to-peer mode. So this is like two phones are talking to each other directly. For example, when you share a contact or a file just by tapping the phones, so both devices will take turns sending and receiving data. So it's a two-way communication. As you can see, we have the bidirectional data exchange, dynamic route switching, as well as device to device transfers. Then we have the card emulation mode, which is very important in daily life. So here your phone behaves like a smart card. So when you tap on your phone for payments or a metro entry, it is acting like a debit card. So the existing payment machine knows that it's a phone, so they just treat it like a normal card. So here the device will act as a passive card, and it is compatible with existing infrastructure, as well as it supports secure element integration. Now, the third mode is the reader writer mode. So, finally, in this case, the device will actively read the data from the NFC tags. So, for example, you're scanning a smart poster or checking product details in a store. So, it can also write data into NFC tags in some applications. So, it can read and write NFC tags, support NDF data format, as well as it is used in smart advertising. So overall, these three modes will define how NFC devices will interact with each other. Now let's come to the internal components of NFC systems. So the four main components here are as follows. So first, at the core, we have the NFC controller. So this is basically like the brain of the system. It manages how signals are sent and received and controls and the entire communication process. So then comes the host control or the HCI. So you can think of it as a bridge between the NFC hardware and the phone software. So it allows the apps to use NFC features without directly dealing with the hardware complexity. Then we have the antenna, which is very important. So NFC works using electromagnetic fields. So the antenna is responsible for transmitting and receiving signals. So that's why NFC only works at short range, usually a few centimeters. So finally, we have the secure element, and this is the most critical part of the security. So it stores the sensitive information like payment details, cryptographic keys, and it is designed to be tamper resistant, which means that it protects the data even if someone tries to hack the device. So together, ensure that NFC communication is not only fast but also secure and reliable.
Okay, I'm Jopsy. Let me begin by explaining what NFC authentication actually means. In simple terms, authentication in NFC is the process of verifying the identity of devices before any data exchange takes place. This is critical because NFC communication happens over very short distances, which is often creates a false sense of security. Looking at the image, on the left side, the authenticated communication includes the identity verification, encrypted data, and secure transfer. So it is marked as secure. On the right side, unauthenticated communication has no verification and unprotected data, which makes it insecure. Also in the diagram, the authenticated communication uses secure element while unauthenticated communication bypass it. So we will discuss it in the next slide. In the authenticated and unauthenticated NFC, this slide clearly compares both, starting with the authenticated NFC communication. Here, devices verify each other's identity before exchanging data. The communication is encrypted and secure protocols are used. This ensures a high level of security and protects against common attacks like spoofing, phishing. This is why applications like contactless payments rely heavily on this authentication. In contrast, unauthenticated NFC communication that does not perform any identity verification. Data is transmitted in plain text and the system is blindly trust the incoming signals. While this makes the process fast and convenient, it significantly increases the security risk. Another key difference is user awareness. Authenticated systems often require user interactions such as biometric verification or PIN entry, whereas unauthenticated systems operate automatically without user consent. So the key takeaway from this comparison is that authenticated NFC prioritizes the security and trust, but the unauthenticated NFC prioritizes convenience, often at the cost of vulnerability. So in the next slide, we will see why this lack of authentication is risky. Now let's look why this absence is dangerous. So the first major risk is data manipulation. Attackers can modify NFC tags to redirect users to malicious website or inject harmful content into the device. Next is phishing. Since the smartphone does not verify the source, users can easily be redirected to the fake login pages that limit trusted applications like banking or payment systems. Another serious issue is eavesdropping. Because the data is not encrypted, attackers can intercept and communication and extract sensitive information. Finally, the spoofing or impersonation attacks can occur, where malicious devices pretend to be legitimate NFC tags or readers. This makes it extremely difficult for users to distinguish between genuine and fake sources. All these risks arise from a single weakness, that is the lack of authentication. So in NFC systems, trust without verification can directly translate to an vulnerability. Thank you.
Okay. Moving on, now we'll be discussing about the security vulnerabilities in the NFC systems. Talking about the NFC system, as it is a wireless type of communication, it always has the vulnerabilities all throughout the structure. Some of the leading vulnerabilities which are very vulnerable and can put your systems in the risk are such as the lack of encryption. This is where the system actually where the data being transmitted is not being it is not being actually encrypted. The next is the no authentication. This is where the system actually does not validate a user who is been whose card or whose the mobile has been used for the data transmission. Next is some of the data tampering, the data being transmitted, being modified or tampered so that they can get a different type of data which does not have the access to from the user. Next is automatic execution. Some of the those are where the some of the actions can be performed without the permission of the user or the authenticator. This leads all usually make into the system very vulnerable, such that the kind of data loss or system loss. Next comes to, this thing is the phishing attack, where an hacker or an intruder sends a phishing email to to an your new user such that he can get the keys or the primary keys which can be used later for for any malicious kind. Let's dive into some of the major major vulnerabilities. This is the automatic execution of the actions. Talking about why is most dangerous are due to the automatic execution. Any kind of malicious actions can be performed by the hacker, which can make the software or we can make the organization or the user's policy into a big problem. This is widely present because of the behavior of the NFC card, which make NFC usage of the NFC enabled apps. The impact is that it leads directly to the NFC phishing attacks. Users unknowingly open the malicious website, which can make the user's account into vulnerable. That's it from me. Now let's move. Kanish will continue from here.
Hello everyone, myself Kanishk Maheshwari. So now let we look into the mechanics of the relay attack. So basically, to understand how an attacker breaks NFC, we have to look under the hood at the protocol itself. Most people assume the 4 centimeter range is a coded security feature. It's actually just a physical limitation that attackers have learned to bypass. So first, let's talk about the protocol gap. Most NFC cards and smartphones use the ISO or IEC 1443 standard. The fundamental flaw here is the lack of distance bounding. When your phone communicates with a reader, it only measures the response. It asks, is the data correct? It does not measure time of flight, which is how long the signal takes to travel, because it doesn't time the signal. The phone can't tell if the reader is right next to it or if the signal is being looped through a server halfway across the globe. So there's the hardware duo. This exploit is carried out by the what we call the hardware duo, the proxy or the leech. This is a hidden device near the victim. It could be a compromised smartphone or specialized tool like Flipper Zero. Its only job is to not is to sniff the victim's NFC field and capture the data. Then the emulator or the ghost, this is the device at the target location. For example, a payment terminal. It pretends to be the victim's device, mirroring the data captured by the leech. Finally, we have the bridge. This is the networking component that makes the attack wireless over long distances. The leech and the ghost use Bluetooth, Wi-Fi, or even 5G to tunnel those NFC data packets. They create a digital wormhole, allowing an attacker to tap a card in London and have the payment processed in New York in milliseconds. So in next slide, we will see why smartphones blindly trust. Uh, why doesn't so I can ask, why doesn't the phone just ask for a password first? The answer is that smartphones are designed for a seamless user experience, which often comes at the cost of security. Here are the first zero authentication handshake. Most NFC interactions involve this. Many tags use the NDEF or NFC data exchange format, which is often unencrypted and read only. Think of it like a digital billboard. The phone assumes that if it can hear the tags broadcast, the information must be legitimate. It doesn't require a handshake or a key to simplify read the data being pushed to it. Then there is a issue of background tag reading. On modern iPhones and Android devices, the NFC control is always on. And when your screen is off, the phone is scanning the environment for specific NDEF records. This means a malicious tag can be trigger an action like opening a phishing URL or downloading a configuration profile without you ever touching your phone or hitting accept. Then implicit trust. This all boils down the implicit trust. The operating system operates on a dangerous assumption. It assumes a user never be within a 4 centimeter of a malicious device, and intentionally the OS treats physical proximity as a substitute for digital authentication. The designers thought if the phone is this close, the user must want this to happen. Attackers simply exploit that politeness to perform fraud right under our noses. So, in short, the phone isn't being hacked in the traditional sense. It's simply following its programming. It trusts the air around it, and in a world of high-speed wireless networking, that trust is easily betrayed. So, thank you. That's all for me.
Myself, Bharat. Now we'll move into the demo part. For this demonstration, we created a controlled, safe environment to simulate a real-world NFC phishing attack. The purpose is purely educational and no actual data is collected or stored. In terms of hardware, we used an NFC-enabled Android smartphone to interact with the NFC tags. We also used black NFC cards, which acts as a medium to store the malicious link. A laptop was used to develop host the phishing website. For software, we used the NFC tools applications to write data onto the NFC tag. We created a simple fake login page, used HTML and hosted in a GitHub pages, which provided a live URL. A website browser is Chrome user to automatically open the link when the NFC tag is scanned. In the configuration step, we embedded the hosted web pages link into a NFC tag. When the phone tag taps the tag, it instantly opens the phishing page, simultaneously a real attack scenario. Now my teammate will demonstrate how the setup works in real time.
So hello everyone. I will continue with the practical part. So in this, I am giving a step-by-step demo process. First, we have to set up the tag. So we set up the tag with the phishing link. Then we have to keep the NFC card near the victim's phone within the 4 centimeter mark so that the phone can scan the NFC and redirect into the phishing link. So when we place the phone within the 4 centimeter of the NFC card, the victim's phone automatically scans the card and it redirects to the phishing website we made. Then depending upon the website and the information the victim provides, we can do the exploits we needed. So this is the practical part. Here we are looking at the payload preparation. This is the lightweight HTML and CSS script designed to perfectly mimic a standard university captive portal. Especially, we have a section expired login screen. This page was hosted on live through the GitHub live page. Then this is our delivery mechanism. This is a passive NFC card operating within a wireless personal ID network. We formatted this card with an NDF or NFC data exchange format. Record programs to store the URI of our spoof login page. Then this is how the exploit triggers. The moment the target smartphone comes within the 4 centimeters of the card, the smartphone active NFC control generate a magnetic field powering the microchip and instantly pulling the NDF payload. So we can see the critical vulnerability in action. The mobile operating system stack dispatch system automatically passes the data and immediately launches the web browser. So the smartphone successfully verifies that the link is formatted correctly, but it inherently lacks the ability to verify if the source of the link is authentic or malicious. So it exhibits the blind trust. Because the victim's phone initially initiated the tap, perhaps believing they were scanning a legitimate campus Wi-Fi touch point, their brain assigns a false sense of security to their digital response. When this spoof login page appears, the social engineering loop is completed, making credential theft highly likely. This proves that a secure wireless architecture cannot rely on physical layer of trust alone.
So, hello everyone, my name is Akil, and now I am going to explain about advantages and disadvantages of NFC technology. Firstly, we look into this. NFC is a game changer in modern communication only because of these three things, which are called instant, secure, universal. I will explain these three things in a simple way First, we look into the instant. Basically, NFC is a short-range wireless technology that allows devices to communicate when they are very close within 4 centimeters. And it is universal. Why? Because it is widely used in smartphones for applications like contactless payments, access cards, and quick data sharing. And also, it is very powerful because it is an instant, secure, and universal available in the more devices. Now we look into the in detail advantages of NFC technology in the next slide. So first advantage is ease of use. NFC is extremely simple to use. You just tap your device, no need for pairing, passwords, or any manual setup. And the second advantage is short range security. Because NFC works only within a very short distance, typically within 4 centimeters, it naturally provides security. An attacker would have to be extremely close to intercept the communication. And third is ubiquitous in smartphones, which means NFC is already built into most modern smartphones, both Android and iOS. So users don't need any additional hardware. And the fourth advantage is ultra fast transactions, which helps to make the transactions very fast. And the fifth advantage is versatility of applications. So NFC is used in many areas such as mobile payments like Google Pay, Phone Pay, and all, and also healthcare systems, smart posters, IoT devices. And the last final advantage is low power consumption. So this is, we can say this has one of the biggest advantages for NFC. Do not requires any battery. They are passive devices which makes them energy efficient and long lasting. So now we'll look into the disadvantages of NFC, which is in next slide. First disadvantage is very limited range. As we see, the range of the NFC technology is just within 4 centimeters. So this is the basic disadvantage for the NFC. And the second disadvantage is slow data transfer speed. It has a maximum speed of about 4 to 4 kbps, so which means much slower than Bluetooth or Wi-Fi. So this is one of the main advantage disadvantage that we can say. And the third disadvantage is vulnerable to relay and MITM attacks. So if the proper security measures are not implemented, attackers can easily perform attacks like man in the middle attacks where communication is intercepted and manipulated. And the next disadvantage is no built-in authentication. So in this NFC, it does not include any strong authentication. So this means unauthorized devices can read unprotected NFC tags and all. And the next disadvantage is device compatibility issues. So not all the devices support all NFC standards. So this can lead to the compatibility issues. And the last final disadvantage is mental interference. So NFC signals can be disrupted by metal surfaces. Even phone cases with metal can affect the performance. So this was from my side. Now my teammate will continue from here. Thank you.
Okay, myself Sunil. Now let's look at how we can secure NFC communication. First is encryption. Even if someone intercepts the signal, they cannot understand the data because it is encoded using algorithms like advanced encryption standard. Next is mutual authentication. Here both the sender and receiver verify each other before exchanging data. This prevents unauthorized devices from connecting. Then we have tokenization, which is widely used in payment systems. Instead of sending actual card details, a temporary token is used, making it useless for attackers. Another important measure is biometric authentication, like fingerprint or face recognition. This ensures only the authorized user can approve transactions. Finally, secure elements are hardware components inside the phone that safely store sensitive information like payment credentials. Next slide. In the future, NFC security will become even stronger with advanced technologies. One major improvement is AI-based threat detection, where systems can automatically identify suspicious activities like unusual transactions or repeated access attempts. Another advancement is a dynamic encryption keys, where keys change for every transaction, making it almost impossible for attackers to reuse intercepted data. We will also see end-to-end secure channels, ensuring the data is protected from the sender all the way to the receiver without any exposure. Additionally, behavior-based authentication will analyze how a user normally interacts with with their devices and detect anomalies. Finally, improved NFC standards will include stronger built-in security features, making NFC communication safer for future applications. Thank you. Now my friend Manoj will continue.
Thank you, Sunil. Myself, I'm Manoj. I'm going to explain about the real world examples of the attacks in the past. Now, NFC tag tampering in public places. This is a very common example in NFC tag tampering. Attackers place malicious NFC stickers over legitimate ones in public places like posters, payment points, or information issues. When users tap their phone, they are redirected to harmful websites instead of internet services. And next one is the security researchers have also demonstrated NFC-based phishing attacks, especially targeting the banking and login systems. In these cases, users were redirected to fake websites that look identical to real banking or institution pages. And the next one is the in earlier Android phones, there were vulnerabilities where NFC tags could automatically open URLs without requiring confirmation. This made such attacks even easier and more dangerous. And another one example is the tap to connect Wi-Fi scam, where attackers plan NFC tags labeled as free Wi-Fi access. Users tap their phone expecting internet access, but are instead redirected to phishing pages. These examples shows the NFC attacks do not require complex tools. They are low cost, easy to deploy, and rely heavily on the user trust. This is why awareness and the proper security measures are very important. Thank you. This is all. This is all from our group.